Thank you, everyone, for attending. So today we're going to talk about the Oracle Critical Patch updates, and specifically we're going to talk about the July 2011 update. And we're going to focus in on the database impact. Last week we did a session for the Oracle E-Business Suite and the impact on that, and today we'll focus specifically on the Oracle database. So for those of you not familiar with Integrity, Integrity exists to basically bridge the gap between databases and security. Our main goal and focus is really to help people secure their Oracle databases. And so we've got a number of services that we provide, both design and assessment services from the Oracle database, as well as the Oracle E-Business Suite. And we also have a tool, App Sentry, that basically helps automate the security assessment process and can provide you that periodic updates and so you can assess your security on a continuous basis. So one of the questions we always get is, how does Integrity know so much about the Critical Patch updates? Well, we've found over 70 security bugs in the Oracle products over the last 5 years, and we're still very active in researching and opening security bugs with Oracle. So here's a list of some of the bugs we've found over time, and we are referenced this quarter as well. So today we're going to talk about the background of the Oracle CPUs, delve into the vulnerabilities to a certain degree, and then we'll talk about the patches, and then talk a little bit about patching strategy and how you should address this quarter's CPU for the database. Feel free, if you do have questions throughout, to enter them in the questions, and we'll kind of follow up with questions at the end. So let's first talk about the background of the CPUs. So the Oracle CPUs have been around since January 2005, and they've fixed over 1,300 security bugs in the Oracle products. And when we talk about the number of security bugs during this presentation, we've actually normalized the numbers for just the core Oracle products. So whenever we talk about having 1,300 security bugs fixed in the last 27 CPUs, we're actually talking about just those Oracle bugs in the database, the application server, the business suite, PeopleSoft. We've actually taken out all these Sun Solaris bugs, OpenOffice, VirtualBox, all those other Oracle products that they've bought over time. So these numbers are really just the core Oracle products that most people kind of think of when they think of Oracle. So in the database, 420 bugs have been fixed over time. That averages out to about 20 bugs per CPU, and so fairly significant. A lot of people kind of ask why the Critical Patch updates, how did this process get started? Well, in the 2004 timeframe, Microsoft had moved to a monthly release schedule. And then Oracle was getting a lot of pushback from customers because the way the process was working was all of a sudden one day people would be send an email and say, oh, security bug, you need to patch all your databases right away. And that became very problematic for many Oracle customers that have routine downtime windows, month-end close windows, quarterly close windows, things like that. So Oracle moved to this quarterly process and kind of was starting to bundle up all the bug fixes into a larger release. And they set it this Tuesday closest to the 17th day of the first month of the quarter. And so the goal here is to actually avoid month-end close, quarter close time frames and freezes that many customers have. So most customers will be outside the year-end freeze, quarterly freezes, month-end freezes typically last the first week of the month. So it works fairly well. And Oracle documents this out fairly well, and so you know moving forward over the next 4 quarters exactly when the CPUs will be released. And in this case, October 18th of this year, and then January 17th of next year. So we actually had very positive feedback from most customers on the quarterly patch cycle. Some people, I think, would like to move to semi-annual, but quarterly at least gets the bugs through Oracle and fixed in a timely manner. So one of the issues people have is, well, this has been going on for 27 quarters. Obviously, these things are done. Oracle has to have fixed every single bug in the database, right? Well, this chart shows, the blue bars there show how many database bugs have been fixed per quarter since the start of the CPU process in January 2005. And as you can see, the numbers are declining, but aren't basically going to zero. And Integrity is looking at what's open in the queue at Oracle in terms of bugs by talking to other security researchers, what we have open internally with Oracle. And we estimate that CPUs for the database will probably be coming out for at least another 2 years. So think about another 8 quarters of this. So if you don't have a well-defined CPU process at this point, it will continue at least for 2 years, probably longer. The squiggly line up to the upper right is the severity of the bug. So this is basically the maximum CVSS score for each CPU. And what I've done here is actually taken the maximum number from each CPU and kind of graphed it out. And as you can see, the number kind of moves around. The database number hovers around 7, has a few peaks up to 10. Those cases were actually fairly serious Windows security vulnerabilities, but for Unix and Linux platforms, that number still hovered between 7 and probably 6.5. The red here is actually indicating for the Oracle E-Business Suite. So you can kind of see the severity of the bugs is pretty constant over time, sometimes having a peak, sometimes having a valley, but really moving forward, most of these bugs are severe bugs. And we'll talk about the CVSS scores in a second, and the reason why a 7 is actually a very serious database bug, even though the scale is between 1 and 10 for the CVSS scores. So another area of concern that you need to at least be aware of in the impact is the bug process actually at Oracle and how it works. So what happens is a customer like yourselves or a security researcher like Integrity actually reports a security bug to Oracle. You either do it through an SR, if you're a security researcher, we actually have a direct line to Oracle. And what happens is Oracle researches the bug and develops the fix. One of the key points here is the person who actually found the bug is never told by Oracle what the fix is. They're not allowed to test it. So over time, maybe between 5 and 10% of the bugs are actually reoccurrences of bugs, because what happened was Oracle would actually fix the bug, but fix it just basically the bug itself, not in the way it was presented to Oracle, not truly going through and saying, okay, every case that this could be exploited in every vulnerability. So you actually see a lot of bugs reappearing that Oracle fixed it but didn't actually fix it appropriately. Then the next part is Oracle actually updates the main code line first. And what they're doing is actually including in the newest code and then backporting it back to all the other versions. And then finally, between 3 months and 3 years, Oracle issues a CPU process. It issues a quarterly CPU that the bug is fixed in. 3 months is very optimistic for an Oracle bug. Most are coming out. Now it's a little bit better, maybe between 12 and 18 months. Integrity, we have a few bugs open currently that's over 3 years old. So these bugs are not fixed very quickly in some cases, especially if they require a lot of regression testing or in fairly old versions, things like that. So one of the key aspects of this, and a lot of people don't understand, is when you actually get a CPU or a new version, that CPU fix may not actually cover a newest version, because what happens in scenario A is Oracle gets notified, they fix in the main code line, and it just happens that they get a CPU out fairly quickly, so that bug actually comes out in a CPU. But what happens is Oracle actually has to backport that fix to, for the database alone, can be between 50 and 70 different patches by the time you take every different version across every different platform. That's a lot of work on Oracle's side. So what happens in many cases is scenario B, where Oracle's notified, if they fix it in the main code line, then they start the backporting process. So that single bug actually has to get backported over 70 times in a lot of cases for the database, because you just multiply the versions times the number of platforms, and that becomes a lot of individual patches that have to be developed, regression tested, that type of thing. So what's more likely is happening is that bug is coming out in the newest versions. Last quarter we saw that very dramatically. We had a number of bugs were actually not even fixed in 11.202 that had just come out because they were actually already included in 11.202. So when you upgrade to 11.203 of the database, which will be coming out probably in the next year, you are actually getting a number of hidden security fixes, and there's no notification, the readmes and the bug notes. You would never know that they might be fixing 5, 10, 15 security bugs in that new release. Because what's happened is those made it into the new code line, and the new version came out from that code line, and then they're still in the process of backporting it. So when you're actually installing a new version, such as 11.203 that will be coming out in the future, there's actually a lot of hidden security fixes in there. And a lot of people don't understand that process, but it's important to know that, and one reason to keep up with the latest versions. Another point of contention, especially right now, is with Oracle and the CVSS. So, and we'll jump out and look at the risk matrices in a second, and you'll see some of the CVSS scores. But basically, CVSS is a common vulnerability scoring system. And what this is an industry metric that's used by Microsoft, Cisco, Oracle and a number of other large companies to actually provide a baseline metric for all security vulnerabilities across everything. So it's for databases, application servers, operating systems, network devices. So anytime there's a security vulnerability by one of the big companies, typically it has a CVSS score. Or these can also be calculated out. So there's a number of CVSS calculators available on the internet. And it's a fairly well documented standard. But the key for the standard is it was designed for network devices and servers. And so the key is if you have a server and I can gain root access, that's a 10. But if I can't gain root access, I can't really ever get over a 7. So the metric is really biased towards taking over the entire thing. But the entire thing designed in the metric, and basically the way the metric reads if you go through the standard, it's very clearly you have to take over the entire device. And in this case, if you take over an entire database, that's not an entire device. And so a number of security researchers and pundits have really criticized Oracle heavily that they're messing with the CVSS scores to make their problems not as severe. But what's actually happening is the problem is actually with the metric, not Oracle. Oracle CVSS scores, based on the way the standard reads, will always be low because you can take over the entire database, but it's very hard to actually get root account. So if I exploit a vulnerability, I can very easily take over the database. I can most likely do something with the Oracle account, but it would be very difficult for me to actually take over the entire server by exploiting an Oracle vulnerability in the database. So the realistic maximum is really 5.5 to 6.5. So the key is whenever you're talking to maybe your chief security officer or someone in the security department, you say, well, we have these Oracle security bugs and they're all 6.5. Well, they may say, well, that's not very serious. We've got 9s and 10s we're trying to get patched right now. 6.5 we'd actually put out for a year. Well, 6.5 means you can take over the entire database fairly easily. So Oracle has included partial plus in the advisory, and we'll kind of show you how that works. So the key is, even though some of these CVSS scores seem low, you can pretty much take over the database with almost any of these. And we'll kind of go through the advisory and show you which ones are partial plus. And you'll think, well, ooh, that's a 5, and that's still a partial plus. So take that in mind whenever you're reading the CVSS scores, or especially when you're talking to an IT security person and referring to the CVSS scores. So what we'll do real quick here is we'll actually jump out to the advisory and show you what we look at Integrity when we bring up the advisory. So I'll bring it up here. So this is the Oracle CPU page. So if you just search Oracle critical patch updates in Google, it actually shows up as the first one. And one of the key things is Oracle does put out the next 4 CPUs. So if you're ever in question and you're talking about how you're going to do your patching and what your downtime windows need to be and how you can fit the CPUs into that patching process, you can actually look out and know exactly for the next year when the CPUs will be coming out, so you can try to proactively schedule these out into the future. And the key planning assumption is, yes, you have to apply the CPU database patches. Last quarter, April, 1 out of 20 of the last 27 were optional depending on what components you've had installed. So 26 out of 27 in the last 5, 6 years have all been mandatory. So I'd always assume moving forward that the CPU patches are mandatory. So then each CPU is out there. So what we'll do is kind of jump out here to the CPU advisory. And one of the key aspects here is they clearly state out the versions. And you do need to be aware of the versions because Oracle is trying to limit the number of database versions they have to support. And a really good way to do that is anyone who's security conscious, force them to only have a few different versions of the database running and very quickly desupport. So the key point here is if it's over 18 months old, that version of the database, unless it's a terminal version, is probably not supported. And I have a chart showing it in a few slides that will actually show you which versions are coming up for desupport when. And a lot of people are actually shocked at when they read the dates, like, oh, wow, that's not too far away for a major version that we have running all over the place. And then if we go through, the rest of the advisory is pretty much meaningless. There's not much here in terms of deep information. It's a lot of just boilerplate that comes out with every CPU. One thing we always look for is your name mentioned. Yep. So Integrity was mentioned as a security in depth contributor for this quarter. So that's always a good thing for us and happy thing that Oracle's actually moving forward and fixing things. The security in depth contribution is actually that we provided a lot of information. We found some weaknesses in some of the Oracle products that weren't necessarily an Oracle critical patch update vulnerability, but Oracle actually fixed anyways and improved the overall security of the products. So kind of the main meat of this advisory, and generally you really don't even have to read this because really the patches are mandatory except for a few occasions, and Oracle really wouldn't tell you that anyways, but it's kind of nice just to at least browse through and see what kind of vulnerabilities are in here. And I'll kind of look at these more in depth in a few minutes, but I'll highlight some of the information that might be useful for you when you're going through it. The first is the CVE score. A lot of non-secure people don't know what this number is, but the CVE score is actually assigned by a group called MITRE, and these are actually assigned for almost every security vulnerability that's ever discovered in any product, including Microsoft, IBM, Cisco, just about any product available on them as a software or a hardware device. And what these are is a common identifier. So everyone who talks about this vulnerability will now use the CVE number, and which is nice. So if you actually just type that CVE number into Google, you can actually get more information about that specific vulnerability if it's been published, and it'll pop very quickly. So if there's exploit code, more details, things like that, it's actually a great way to find out more specifics about one vulnerability. The second thing is looking at the component. So a lot of these are actually in the core RDBMS this quarter, which is actually a little different than previous quarters. Previous quarters have tended to, in the last year to 2 years, focus more on those optional components, those ancillary things that are in the database that aren't really just the part of the core database. And in some cases, you wouldn't be running. Things like Database Vault, Oracle Spatial, those type of modules. It's been rare to actually see a lot of core RDBMS bugs. A lot of times there might be one. This quarter, there's about 8 or 9 of the 13 are all core RDBMS. So this kind of goes back to the point that, yeah, Oracle's fixing problems, but there are still problems in the Oracle database. We were kind of thinking that all the low-hanging fruit, all the kind of really easy-to-find bugs in the Oracle database have been found, and everyone's moving on to try to find it in other components of the database. And that doesn't seem to be the case, at least with this quarter, and we'll see if that trend continues. The next aspect is what privileges are required, and it's actually kind of interesting to see that when we look through some of these. So this one requires create library or execute on a very specific package, which is not normally granted out. This one is actually sysdba. So we're actually seeing very high-level privileges, even though this is one of the most severe bugs in the CPU. We're seeing that they actually require a lot of very severe, significant privileges that might not be granted out. So if you have sysdba already, in a lot of cases, I'm not going to be concerned that you can take over the database because you can already do anything you want to the database. Where a lot of times these come into play is if you're working with Database Vault and other areas where you've got a lot of segregation duties within the database and you're actually trying to prevent someone from accessing some other data, even though they have very high privileges, you can actually block their access. Again, here the CVSS scores now are here. So these two vulnerabilities are 7.1. So that's a fairly severe Oracle vulnerability. And the key here is these are all completes, which is actually kind of rare to see, except for if they're Windows vulnerabilities. So most likely these vulnerabilities can be actually exploited on the Oracle running on Microsoft Windows, but most likely on Linux or Unix, these would only be partial pluses. So I can take over the entire database, but I really can't take over the operating system. But on Windows, that is not the case. A lot of times on Windows, I can take over the operating system, administrator type accounts. But if we scroll down in the advisory, now we'll go through, well, those were pretty significant vulnerabilities. Now we're down into 6.5, again, core RDBMS. But these are very severe vulnerabilities because, hey, I only need create session. Low here is how difficult it is to exploit. And oh, by the way, I can read everything in the database. I can write everything in the database. So these are actually fairly severe vulnerabilities when we look at it. So anyone who can connect to your database can basically, with low complexity, not very hard to exploit. So if someone publishes out some exploit code, just about anybody can do it, even the lowest newbie developer, or maybe somebody in AP who's got a little bit of IT, computer knowledge, can basically take over the entire database. And a fun aspect here is, well, Oracle has really been stressing on how good their new development process is. Well, these bugs are in new code. If we look at these 3 bugs, and there's actually 4 here, we go through these 4 bugs. These 4 bugs are all in 11G only. These are not code, because a lot of Oracle security bugs you find, well, they've been around forever. It's just it happened to be now that someone found them. Well, these bugs are actually all in 11G, so this is brand new code from Oracle in the last couple of years introducing security bugs. So anyone who can think that, well, Oracle's immune to developing security bugs and their processes are so great, so any new code coming out of Oracle is going to be perfect, that's not the case. And this CPU very clearly highlights that we've got 4 new bugs that are in brand new 11G code. And if you look through actually some of the code itself, what happened was they tried to make it secure and they actually didn't quite do it completely. And so if you go through, you can actually circumvent what Oracle did was in their attempts to make the code secure. And again, this is in case of the dynamic SQL, and they're trying to sanitize the input, but they didn't quite do it right. So that's kind of a very clear example of some of the security vulnerabilities, and just kind of walking through and what we look at in terms of the risk matrices. So we'll pop back. So that just kind of gives you a little bit of information about what's happening in the CPUs, advisory, and kind of how we look at it when we look at it in Integrity. So we'll now dive in a little bit more into the vulnerabilities themselves and kind of give you some more information. And what here I've done is actually group them together to give you a little bit more information. So we'll kind of walk through these pretty quickly and give you a little overview of what's happening with some of the vulnerabilities. So again, the first 2 were actually 7.1s on the CVSS scale, but again, they need create library or sysdva. So fairly powerful privileges are needed. These are actually within the ability to access outside libraries. So if I can create a library and access some of the libraries, either Oracle libraries or Windows libraries or Unix and Linux libraries, I can actually quite do a lot. So anyone who's granting out the create library privilege to anyone should be very careful. This is actually a very powerful privilege. It's not granted out very often during our assessments. We really don't see this as a problem, but it does happen occasionally, especially to developers. So you have to be fully aware. If you're granting create library to a developer, it's very powerful. The next vulnerability is basically within 2 database packages, and so basically it's a DBMS HS parallel and its sister package, DBMS HS parallel metadata. The key here is DBMS HS parallel is granted to public. So the only thing I need to do is to exploit 3 out of these 4 vulnerabilities is have create session privilege. That's very powerful. Again, it's only in 11G fortunately, but anyone who has 11G database, if I can connect to your database with any sort of account, so it just has to have create session, so there's no other privileges there, I can basically fully take over, read, and write any data in the database. Because, again, this is basically granted to create public. It's a very powerful type exploit. Fortunately, there has been no exploit code published yet, but anyone who can quickly reverse engineer what's happening in the package, do a comparison between the old package and the new package, can very quickly develop an exploit for this. Again, what's happening is Oracle's, because the way these packages work is they're working on dynamic objects, so you pass in a table name or something like that, so behind the scenes Oracle has to actually do execute immediates on the tail SQL statements, and so they have to dynamically generate this statements, because within SQL you cannot do bind variables for like the table names or the schema names. So they always have to generate the SQL statements and then do an execute immediate. Well, they aren't sanitizing their input properly, so I can actually then execute other things. And since this is defined with definer rights as the packages, they actually execute as sys. So if I can kind of find something I can do with these packages, it becomes classic SQL injection. It gets executed as sys, and then basically I can do anything I want as the sys user. I can execute different functions, things like that. So again, just connect to the database, do a couple of SQL statements with calling DBMS HS parallel, and I can take over the entire database. Next vulnerability is in the XML Developers Kit. The XML Developers Kit has had a lot of issues over time, so if you don't need it, don't make sure it's not installed. Again, I need an authenticated session, but this is either a buffer overflow or some issue within the processing, because what was patched here was the libxml. As we kind of go through this, one of the questions is always, how do I test it after I install these? Oracle doesn't give me enough information to actually test it. And what's happening in a lot of cases is these are anomalies. These are fixes to things that shouldn't be happening. As in this case, is it's within one library's patch. So these two bugs here, the only change is basically this libxml file is actually being updated. And so it's one library gets updated, and most likely what got changed in that library was it could be a buffer overflow, in which case the only change the coder made was checking the length of the input. Really, there's no functionality change, nothing else. That's how most of these bugs work. So there's not a lot of testing to do as long as I just check generally what XML developers kit's doing, but most likely I wouldn't even notice any kind of change because the changes are so benign that typically happen. That's not always the case, but probably 95% of the time this one library gets updated. In the DBMSHS parallel, basically they're just updating the package, and every time they create the dynamic SQL, they're just adding another sanitizing statement around it. So as long as you're not using quotes and weird spaces or anything trying to pass it as the table name, nothing should ever change. The final bug here is a denial of service issue. A denial of service means I can basically take your database and stop people from accessing it. So that's classic denial of service. The key here is most every denial of service before is it within the Oracle networking, so the listener or some part of the networking. And what would happen there is I can basically send a special packet via the network to the listener, and it basically crash the listener. The database would stay up, but the listener would crash. And so basically no one could connect to the database, therefore an effective denial of service. This is a different bug here versus previous quarters. Almost always in the previous quarters, it was a network listener type denial of service. So the listener would crash, but the database would stay up. In this case, this is within the core database, and it's far enough along in the authentication process or some part of the processing that you don't need authentication yet, but it's remotely exploitable. So I start my connection to the database, and most likely this is a CPU exhaustion issue. So what can happen is I can start a whole bunch of connections, and they start spinning the CPU because they go in an infinite loop or something, and then basically if I can do that enough times, I can bring down the entire database. And so again, this is a little bit different, that I can stop the entire database versus just stop the networking components. For most people, this probably isn't an issue, but if I can kind of somehow exploit this very quickly on a database for your key database that may be running manufacturing or something, I can basically stop your manufacturing line. So those are the type of issues that would impact somebody for a denial of service. So that's kind of the first set of vulnerabilities. There's 13 total. So the next set is, again, we're seeing a lot of core RDBMS, which is different than most quarters. So very few this quarter are kind of these ancillary components. So, but there is one, database vault. So anyone who's running database vault, there's a huge and significant issue about trying to limit what people can do within database vault. That's the whole purpose of the product. So anytime I can escalate my privileges within database vault, that's pretty significant. So what I'm trying to do is stop DBAs from accessing data they shouldn't. So I've got segregation of duties on the DBAs. So DBAs are typically granted DBMS sysql. Well, there's an issue within database vault that if I'm granted that, I can actually elude database vault and do things that I'm not supposed to be doing, which typically would be blocked by database vault. So this is basically a fix to change some of the rules within database vault and how the DBMS sysql package is handled. Going to the next vulnerability, again, another core RDBMS. So we're seeing a lot of core RDBMS bugs this quarter. So this vulnerability needs create session and trigger assistDBA. Again, a very significant set of privileges are required. But again, here, Oracle 11G only. So we're seeing a number of bugs this quarter that were introduced as part of the Oracle 11G. So Oracle's quality assurance program and security program is probably working pretty well, but still bugs are getting introduced. So anyone who thinks, well, I'm just running 11.2 of the database, and since it's a lot of new code, any of that new code is fully secure. And these are a number of examples where that's not the case. The next vulnerability here is within the Oracle Universal Installer. So this is a very specific issue to 11.105. And probably what's happening here is Oracle is actually writing out some sensitive information like a password out to one of the log files. So if someone has local access, and so this is a very key consideration when you're trying to give developers local file system access to your production environments and what they can possibly do. Because a lot of times they have read-only access to a lot of the Oracle homes. Therefore, they could probably go through some of the log files and actually then go in and find the sensitive information. So one of the key controls a lot of customers have, and you should have also, is limiting access to the local file system on production environments. And again, it's on the last issue here, again, it's a local access issue only. If I can get access to the local operating system, I can then exploit this issue. And this happens to be a very specific issue is because if you're running XMLDB. And again, another reason not to be running XMLDB because there's a number of issues in the product over time. So XMLDB allows you to have an HTTP server or an FTP server running. And what can happen is if I'm locally on the box, I can actually circumvent the authentication controls on the FTP. It'll actually let me write in because it says that, hey, you're local, you have some privileges, and I can circumvent the database account login issue. So that's kind of a brief overview of this quarter's database vulnerabilities. The fortunate thing about this quarter so far is after about a week and a half, there have been no further information disclosures or exploit code written, which is unusual. The number has been dropping off every quarter, and I think what's happening is people are kind of getting bored maybe with Oracle security vulnerabilities and aren't publishing out exploit code, or it's easier for them to sell it. So there have been very few disclosures publicly on the security mailing lists in places. So that's the overview of the security vulnerabilities this quarter. So now let's talk a little bit about the patches. So one of the key aspects about the patches is, I'll kind of do a little bit of background here first, is whenever you install a database upgrade, you always have to install the latest CPU patch. And this catches a lot of our clients because when we do our security assessments, one of the things we always review is, okay, what CPU is installed? And we have tools that actually check and validate that the code has been patched versus just relying on any other metrics or looking at any tables or anything. We actually check that packages are updated and things like that. And we catch a lot of people on this because what happens is if you install, let's say, 11.201 of the database, and you apply the July 2011 CPU, and then you upgrade to 11.202 of the database, what will happen is it will revert the CPU level to January 2011. So let's kind of walk through this again because a lot of people don't understand this. If I install 11.201 with the July, and then we go the 7/2011 CPU, then I upgrade to 11.201, my CPU version reverts. Even though I've got July 2011 installed, it will revert to January 2011 because there is no versioning within the Oracle database. And so it will change my packages that I have installed back to the earlier versions. So whenever you do a database upgrade, always install the latest CPU. So this is the chart that we've put together. Oracle is finally starting to publish this information out. It was only about 3 months ago that actually Oracle got serious about having this information in all the different readmes and things like that. Prior, it wasn't documented by Oracle. If you run Oracle E-Business Suite, the chart to the right is Oracle E-Business Suite. Again, if you install the 12.1.3 patch, no matter what version you have already installed the CPU previously, it will revert back to January 2011. There is versioning within the Oracle E-Business Suite patches, but what they do a lot of times is they actually release the code as a version specific. So the 12.1.2 code will automatically always be overridden by the 12.1.3 code. And it's especially problematic when you go from 12.06 to 12.1.3 or 11i. So be aware, whenever you apply any major upgrade to an Oracle product, always apply the latest CPU patch. And that works generally for most all the Oracle products. Another area is database CPU support. Oracle is being very aggressive about desupporting specific versions. So when we go through for the CPU, the terminal CPU is generally 18 months after the release of the patch set. Or for certain terminal versions, will stay around for a little bit longer. So if you're running 1204, this is actually the last CPU for 1204 of the database. It actually got extended a quarter recently. So if you're running 10205 of the database, July 2013 will be the last CPU, and that's based on the extended support date. So 10205, the extended support ends July 2013. One of the key dates coming up, a lot of people just upgraded to 11201. Well, July 2011 is the last CPU for 11201. 11202 is then supported, and our estimate is July 2013 because 11203 will come out, and then that's basically 18 months after 11202 came out. So these dates are very aggressive. So when you do planning and thinking about database upgrades, think about always doing a database upgrade at least every 18 months, and that's the only way you can stay current with the CPU support. And there's not a lot of wiggle room in these. Oracle has been very aggressive over time, and they're pretty close to 18 months. There's not a lot of extensions here. The only time there's an extension is typically if they extend, maybe extended support over a short period of time. Another key set of questions that we get is regarding patch set updates. So Oracle in July 2009 introduced patch set updates. So patch set updates are basically the CPU patches plus a lot of other critical fixes. And the critical fixes are typically defined as database crashes, database corruptions, things that shouldn't be happening are really true bugs. There should be no real configuration changes required, nothing that would change an optimizer. So there's really no new features in PSUs. It's basically just fixing really important fixes that you should have. And the way we look at it is, if you have to apply one-off database patches today, PSUs probably might be good for you, but a lot of DBAs you talk to, for certain databases, like their ERP systems or smaller databases, they don't even know what a one-off database patch is. They've never applied them. But then when you talk to someone who runs massive data warehouses, they're applying one-off database patches all the time. So it's really, if you're applying one-off database patches regularly, then maybe patch set updates might be helpful. The key thing for patch set updates is their new baseline version. So when you apply the 11202 PSU, it's actually updating the version behind the scenes. They don't tell you the version, it doesn't display anywhere. But like the latest 11202, I think, is 1120202. So it's actually updating the version. So what's happening is once you apply the PSU patch, you cannot apply CPUs anymore until you do a database upgrade. So if you've applied 11202 and you apply the PSU, for the entire time you're on 11202, you always have to apply PSUs. You cannot apply a CPU. The only way you can apply a CPU then is if you upgraded to 11203 or some other version. One key aspect for the PSUs is there's a lot of other patches. These aren't minor, a couple patches applied. So we looked through the July 2011 patches for 11202 and counted them up. So for the CPU patch, since they're cumulative, there's 15 database patches. It's been out for 2 quarters. There's 13 this quarter, I think 2 last quarter. So 15. When you do the same count for the latest PSU for 11202, you get 15, plus you get basically 95 other patches that are non-security related. So you're applying a lot of different patches. And so for the PSU, there's 110 bug fixes, of which 15 are security related. All the rest are non-security related fixes. Oracle deems them high priority and won't break anything else. And the question is, risk-wise, are you willing to apply that large of a patch with that many fixes into your environment? If you're applying a lot of one-off patches, you probably are applying a lot of those patches already. But if you're not, why take the risk to apply all those other non-security fixes? So that's a little bit about the CPUs and PSUs. The other question we get quite routinely is, how do I check if my CPUs have been applied? And there's 2 methods. Method that we recommend strongly is looking at sys registry dollar history, or it's actually DBA registry history is the view on it. And basically, Oracle, is, as of January 2006, created this table, and this table will be updated anytime you apply a CPU patch, a PSU patch, or you do a database upgrade. It doesn't work consistently for 9.2.08, but anytime 10.2 and above, it works definitely, works very well. And so basically, this table will contain the information about the CPUs, PSUs, and database upgrades. The reason you want to look at this table versus looking at anything else is the CPU process is two parts. You run OPatch, that updates the Oracle home. The other part of the patching process is actually you have to run cat CPU SQL. And so what happens during the patching is when you run OPatch, it updates the libraries, it updates the package source code, like in RDBMS admin directory. It's updated there. But to get that new PL SQL package, such as this quarter DBMS HMS HS parallel, to get that code loaded into the database, you actually have to run cat CPU SQL. The last step of cat CPU SQL is actually to update the sysregistry dollar history table. So the only way the table can get updated is if you've successfully run OPatch and run cat CPU SQL, so you know both steps have been done. We find a number of databases that actually someone had, one of the junior DBAs typically, they run OPatch, but they forget to run cat CPU SQL. And so, or if you've got multiple databases running out of one Oracle home, which isn't as common anymore as it used to be, they'll update one database but not update 3 or 4 databases. So it's not uncommon to find the database not being updated properly and therefore a record not in registry dollar history. The other method that a number of people recommend is actually looking at OPatch. Again, if you don't run cat CPU SQL, OPatch will show that the patch is actually installed and you don't know that it has been. So that's a little bit about figuring out what the patches are applied. So a little bit about a patching strategy that we'll go through. A lot of our customers basically are fairly far behind. So we've gone through and actually looked at during our assessments and captured the data of when people actually had their databases patched and how far behind they were. So this graph shows by number of months how many months different databases were behind. And this is about 120 production databases, a lot of ERP systems. So as you can see, a number of our clients were patching within 9 months. Many started at 24 months, and then 48 months far to the right were very few. So basically the 48 months were people who had never applied a database security patch. And what typically happened at 24 months were we were also picking up people doing database upgrades. So when you do a database upgrade, you do get some relief from doing the CPUs because it actually has that baseline in it, but you're still a number of months behind. So when we talk about trying to do patching, the standard that a lot of companies that we work with are moving to is N-1 patching standard. So the key is you're trying to get the patches in within the 90-day window. And N-1 is, well, by the time the next CPU comes out, I've got the last one applied. It's very, very difficult to get the patches applied within 30 days. And we don't really recommend you move that quickly because you do have to move it through a standard patching process, apply it to development, test, and then production. You can most likely start doing it within 60 to 90 days, and that kind of gives you enough time to get through a rigorous enough testing process and get it into production within 90 days. So what we have been pushing our customers is N-1 is becoming more of this industry norm. That a lot of people are saying, well, we can't do it within 30 days, but 90 days is becoming more realistic. The patching process is becoming much more routine. The number of vulnerabilities fixed are dropping a little bit, so you're not getting 30 or 40. You might be getting 10 to 15 security vulnerabilities being patched. The patches are cumulative, so even if I fall behind a quarter, at least I can get caught up. And they're producing very few problems. I just went through, so we've been about a week and a half, the known database issues for the database patches. There is nothing on the list as of now. If you talk to a lot of DBAs who apply the database patches regularly now, in the first few years there were a number of problems and patches were often reloaded, a lot of bugs encountered. This is 27 CPUs later Oracle's gotten pretty good at it, so there's not that many bugs. And as we saw, a lot of the updates and fixes are one library. So libxml got updated, and the only thing they fixed in that for one of the bugs was probably just adding a length check into it. So there's not a huge amount of changes within the CPU patches, so people aren't running into many problems. So that's a kind of a high-level overview to provide you a little bit of information about how to basically patch some of the things that you should be looking at. And what we'll do now is open it up for questions.
All right, thank you, Steve. We have a few questions here. First one, just how reliable are the database CPU patches?
So generally, we haven't found a lot of problems at all with the CPU database patches recently. This is a lot of companies are applying them actually without doing much testing at all. If you feel like you do have to test them, we'd recommend you do the same testing as a database upgrade. So if you went from 11.202 to 11.203 of the database, we'd recommend for the CPU patches do similar testing. But we have a few of our clients don't do any functional testing, and they do very little technical testing. Basically, DBAs run it through their cycles a little bit, and they'll do it in development, test, and then production. They might leave a week between those or 2 weeks, and there is no specific testing that's done. They may look through the CPU notes and say, oh, there was a fix in XMLDB, we use that heavily, but and they might test a specific item that they saw in the CPU advisory, but they are not doing a rigorous full regression testing because they haven't run into many problems over the last number of quarters, especially in the last 2 years.
Next question. How long should we wait before applying the CPU patches to our environment?
This is always a very good question because what we do and what we've seen quite often is that Oracle actually reloads some of the patches. So far for this quarter, it tends to be on some of the what we call the ancillary operating systems like ZOS, maybe Tandem, things like that. So as of this quarter, there were 2 reloads already. And so that's not uncommon to have a few reloads. Almost always those happen within the first 2 weeks. So we actually recommend, unless you have a fairly high security posture environment, waiting 2 weeks before you install the patches. Then you are almost guaranteed that there's no reloads. Then after the 2 weeks, apply it to development, maybe wait a few days or a week, apply it to tests, do the same wait, and then get in production. That way you can basically get it in within 5 weeks of release. One of the other ways to actually minimize your risk and exposure is limiting access to the database. As you saw, a lot of these database security vulnerabilities need authentication to exploit. So if I can't connect to your database, it's very, very difficult to actually exploit any of the security vulnerabilities. So if you have ad hoc users or other people just being able to connect, that basically allows them to take over the database. But if I limit access to those people as much as humanly possible, and I know it's difficult because you've got a lot of different interfaces, a lot of ad hoc users, business requirements, but limiting access to the database is a way to reduce the risk as much as possible.
Okay, next one. Is exploit code available for any of the bug fixes in the CPU?
Yep. As of this quarter, so we're about a week and a half into the release, there actually has been no exploit code released. So that's actually been very good. Last quarter, I believe there's 2 or 3 out of 10. Previous quarters, there's maybe been 5. So I don't know if people are losing interest or something, but there has actually been no exploit code. And there are some very good vulnerabilities to exploit in this quarter too. Just create sessions. So DBMS HS Parallel is a very easy package to exploit, and actually to generate some exploit code would not be that hard.
Interesting. Next question. How much testing do we need to do after we apply the CPU?
So basically back to the testing. So we recommend the maximum amount of testing would be similar to a database upgrade. So when you went from 11.201 to 11.202, one of the minor patch sets would probably be the best way to test if you have a rigorous testing requirements. Otherwise, many of our clients are now just applying to patch, make sure it works, immediately apply it to development, leave it for a short period of time, apply it to test, leave it for a short period of time, and then immediately move it into production. There's been so few problems with the CPU patches. With the PSU patches, you might be more likely to get a problem. You might need a little bit more rigorous testing. But the CPU patches are pretty benign. If you go through and look at actually what files are updated, it is core libraries and things, but the changes, the binary changes to those libraries are very, very minor. And it's typically a change is, well, it's a buffer overflow, which means somebody passed in too much data. And the program couldn't handle it, so therefore the extra data became executable code. That's how a buffer overflow works. Well, the way you fix a buffer overflow is you just add in a single line check that says, well, I'm expecting 100 characters, and if I get over 100 characters, basically reject the input. Because in most cases, I should never, ever see over 100 characters, and that's what the developer thought, so, such as a table name. Table names are limited. They're a certain size. It's not a valid table name. The developer said, oh yeah, I can't get over 100 characters as a table name, so therefore that's how he coded it. He never thought that somebody, hey, could actually pass in 1,000 characters, and that extra characters at the end, maybe at 900 plus, actually becomes executable code in terms of the way C works. And that's basically what a buffer overflow exploit is.
All right, Steve, I think that's about wraps it up for the day. That's the rest of the questions. Again, I want to thank everybody for attending our session today.